We're continuing with chapter 10, section 5, dealing with tangents. You'll notice that it says the distance from S all the way to T. That distance we know for certain is 18 units. So label it 18 units. You know that for certain. Well, since they didn't say feet or inches or anything else, just use units. Now, the distance from P to S, the distance from P to this point right here, and the distance from P to this point right here, it's 5. Because as the radius of circle P is 5, and this is the radius. So you're gonna call this a 5. You're gonna call this a 5, and you're gonna call this a 5. Go ahead. What do you notice, Linux?
18 minus 5 would be 13.
So what you're doing right now, because this distance right here has to be a 5, and this distance right here also has to be a 5, then you're saying that the distance from here to right, I'm kind of making sure I don't color over the blue. That distance right there is actually going to be how long? 13.
And then you can make another right triangle and you know.
Or you can do that. No. So that's 13. This is also what? 13. This distance from here to here is 5. Just like this distance is a 5. And 5 and 13 make 8. All right. So the last thing I want you to do is this. From R to right there. And from R to right there, even though I don't know what those distances are, I know they have to be the exact same distance because these are tangent to the circle. So I'm going to call this X. I'm going to call that X. Now here's what I would like you to write down on your paper. I would like you to write down the distance from R to S, that distance, squared, plus the distance from S to T squared. It's going to equal the distance from R to T squared. So we see this leg squared plus this leg squared equals the hypotenuse, which is R to T squared. Now, what is our distance from R to S? What would we call?
5 plus X.
Say it again?
5 plus X.
All right, it's called 5 plus X. I'm just going to call it X plus 5. I like to lead out with the variables. Okay. What is the distance from S all the way to T? We're going to put 18, and we're going to square it. And the distance from R to T. We have an X and we have a 13. So what do we have to add together? X plus 13. So put X plus 13 squared. Now, X plus 5 squared means X plus 5 times X plus 5. Now the fast way of multiplying this is not using the FOIL method. The fast way is just realizing that it's going to be an X squared. 5 plus 5 is 10. If my board would let me write it, great. And then 5 times 5 is 25. I love it when this board lags. It just makes it so much.
Just move you on this side of the question. Remember, maybe because it's too far.
See right there? That's recording. Sorry. 18 times 18 is 324 equals. What is X plus 13 times X plus 13?
X squared.
Okay, that means you're multiplying it times itself, right? So you're right, it is an X squared. What's 13 plus 13? 26. So 26, and 13 times 13 is? 26. Now, what are we allowed to add over here? We're allowed to add those together, right? Okay. Yeah. So you see it right here? When you have x squares on both sides of the equal sign, if you subtract x squared from both sides, they cancel each other out. So here's what you have left. You've got a 10x plus 349 equals 26x plus 169. Okay, subtract 169 from both sides. subtract 10x from both sides. Okay? So, this zeroes out. What is 349 minus, excuse me, 169? What is it? And what's that equal to? 16x. Divide this by 16. Divide this by 16. And what does x end up? 11.25. So right there, you never, ever round until the very end. That's when you round. You don't round at the beginning, you round at the end. So we got to take this answer, and what do we need to do? Plug it in everywhere we see in x. So what am I going to plug in there?
Oh yeah, 11.25.
What am I going to plug in right here?
11.25.
There we go. So everybody, my suggestion is this. Take that side, which is 11.25 plus 5, add it to this side, which is 11.25 plus 13, and add it to the 18. All of those added together will give you your perimeter. I don't need to know the answer. I just simply want you to add these numbers together, and finally that number together. Add it all up, and that will give you your perimeter. Zoom out a little bit. All right, problem number 14. You are trying to find the perimeter of this triangle. That's what you're trying to find. Now, the hint is this. It says A to C is equal to C to B, which is equal to A to B, which lets you know that this triangle is an equilateral triangle. Okay? If all the sides are equal. The one piece of information that they've given you is that they say the length of the radius is 3. Now, yes, I'm only going to focus on one. Which means a tangent line with a radius. This is the whole purpose of this assignment. A tangent line with the radius forms what type of angle? Right angle. That's correct. So right now, put 90 degrees right there. Now, this length right here, it tells us is 3. So I'm going to label that as a 3. Now, you could have drawn this anywhere. I just chose to write it from D to G. Now, how many equal sectors do we have in this circle? How many equal sectors? 6. So understand that if you take 360 degrees and divide it into 1, 2, 3, 4, 5, 6, each of those sectors is going to be a
30, 60, 90.
Now we know for a fact this is a 30, 60, 90. Now I'm going to shade in the triangle that I'm talking about. I'm talking about this triangle right here. Does everybody see that this triangle is going to be the same as this one, and this one, and this one, and this one, and this one? They're all going to be the same. So what I want you to do is I want you guys to write down the properties of the 30, 60, 90. But x radical 3 and 2x. Now, where does the 3 go?
On x.
Right. Because it's the shortest side, so you put a 3 right here. What is x radical 3? What's that going to do? 3 radical 3. And 2 times 3 gives us a? Now, does everybody see where the 60-degree angle is opening? The 60-degree angle is opening which direction? To this side. So what is the distance from A to D? The distance from A to D is 3 radical 3. Now, the distance from A to D is 3 radical 3. Well, what you need to realize, well, hopefully you realize, the distance from A to F would also be 3 radical 3. From F to B would also be.
What about D to D?
No?
I mean D to, what is it? D to E?
Nope.
What is it?
C to E, E to B, C to D, D to A to F, F to B, all the way around the triangle is 3 radical 3.
Oh, 2.
How many 3 radical 3s do we have going around it? 6. So watch, just take 6 and multiply it by 3 radical 3. 6 times 3 is 18. That's your perimeter. Now everybody, I know it's kind of confusing for some of you. This is your exact answer. It's not the approximate value, it's the exact value. The approximate value is what you get when you type it into the calculator. Type in, clear all this out. 18 radical 3, and that gives you that 31.2. 31.2. Round to the nearest 10. This is your approximate. We're going to make that into a 2. We're going to round it up. So if your approximate value is 31.2 units. That's your approximate. That's your exact answer. What would I like to see on your paper? More than just an answer. What I'd like to see on your paper is all of the work that we did. That's what I would like to see. The very last problem you're going to be doing on your own. All I'm going to do is set it up, and you're going to be doing it on your own. I want you to understand the distance from A to F is going to match the distance from A to D. The distance from D to B will be the same distance as from B to E. And last but not least, the distance from F to C is the same distance as from C to E. What you're going to have to do in order to solve for the perimeter of this triangle, you're going to have to set up 10 times the difference of C and 4 and set it equal to 2 times Z. You're going to need to solve for Z and then plug it back in. Now it tells us the distance from C to F is 6 times 3 minus X. What you need to understand is the distance from C to F is equal to the distance from C to E. So we're going to set these expressions equal to each other. And last but not least, tells us the distance from D to B is 12y minus 4. And D to B equals E to B. So I'm going to write 12y minus 4 equals 4 times 1. So what are we going to do on this one? We have to solve for y. Let's plug it back in. This one we have to solve for x and plug it back in. Now I'm not going to do all 3 of them, but you know what? I will choose one. Actually, I'll let you choose one and tell me which one you would like me to solve for, and I will do that. Go ahead, Alex.
Y.
Why? Because I'm asking. Just kidding. Okay, so we're going to solve for y, then we're going to plug it back in. So here's how I would solve for y. I would add a 4 to this side, and I would add a 4 to this side. Then I would take away a 4y from this side, zeroes it out. And I'm going to take away 4y from this side. Remember my board is lagging behind. It usually does. You get 8y equals 4. And you always divide by the number that's in front of the variable. So I'm going to divide both sides by 8. And I get y is equal to 4 divided by 8, which is simply a half. So that's what y is equal to. Now I'm going to take this half. I'm going to stick it right there. I'm going to say 4 times a half. I got to think, what's half of 4? That's 2. So what do I know the distance is from D to B? From D to B is equal to what? 2. And also from E to B is also equal to 2. So that's not my final answer, but I know that side's a 2 and that side's a 2. So that's part of my answer. What else do you have to find? You got to find C to F, C to E, A to F, and A to D. All right. So all you guys got to do is just solve for Z. You know, do a little distributed process right here. Distribute. Okay. Over here, what do you got to distribute first? You got to distribute the what? Distribute the 6. Nope, not the FOIL method, just the distributed property. FOIL method is typically used for just binomials. Okay. Good luck. solve the problem. When you get the answer, make sure your final answer is the what? The final answer represents the whole perimeter of the triangle, not just one of the sides.